Hi, today I'll be showing you how to solve a physics problem involving forces during a push-up. So our problem prompt is a person of mass 60 kilograms is doing push-ups, and we're going to find the force exerted by each hand and foot, assuming the person holds this position. So right here we have a drawing of the person. So our first thing is from the feet to the center of mass, we have 0.84 meters. It's our first distance. And the second distance that we're given is from the center of mass to the hands. And then right here we just have everything written out, so our two distances and then the mass that we're given. So now we have to find the forces exerted by each hand and foot. So we'll begin by having our diagram of the different forces. So here we have our force of the feet and force of the hands both going upwards, because that's due to the normal force and they're opposing the surface that the person is resting on. And then we have our force of gravity at the person's center of mass pulling downward on that person. And these are two generic equations that we'll be using to solve the equation. So our first one is force equals mass times acceleration. And then our second one is torque equals the radius cross the force. So first off, using this force diagram, we can figure out the sum of the forces and come up with an equation based on these. So to sum up the forces, we're going to add together the force of the feet and force of the hands because they're both in the same direction. And then since they're opposing the force due to gravity, we can set them equal to that. So force of the feet plus force of the hands equals force due to gravity. Next, we can go ahead and find our force due to gravity. So we already know from our generic equation that force is mass times acceleration. So our mass is 60 kilograms. And since it's a force due to gravity, we can use the number for acceleration due to gravity, which is 9.8 meters per second squared. And once you calculate these two numbers together, you just multiply them, you'll get 588, and our units are going to be in newtons, because that's what we use for force. So after this, we know that F sub F and F sub H added together are going to equal 588 newtons. So our only problem with solving this is that these are two of our unknowns. So we have to do some algebra tricks to be able to solve the problem. And we can do that by using torque, because whenever we sum up the torques, this is why we were kind of given these two distances as sort of a hint that we were going to use torque. So our distance is going to be r for one of them, and then our second one is going to be, so the first one's going to be 0.84 and the second one's going to be 0.41. And we can set them equal to each other because the person themselves is in equilibrium. So they're not moving. So we'll set the first one 0.84 meters, and that's from the feet to the center of mass, so that's going to be F sub F for our force. And then we'll set this equal to 0.41 meters times force of the hands. So once we multiply some of these together, we can do some algebra tricks. So I'll go ahead and multiply. Well, to solve for one of the variables, I'm going to have to divide one of these over. So I'm going to go ahead and do 0.84 divided by 0.41. The number I get is 2.05. And that's going to be multiplied by F sub F because I divided this one over. And we're going to set this equal to F sub H. So now I have one of these variables, and F sub F is the same as this F sub F, so I can substitute in this quantity into this equation. So we'll have F sub F equals, or F sub F plus 2.05 times F sub F. And we're going to set that equal to 588 newtons. So then this is understood that there's a 1 outside of this from our algebra rules. So then we would just add together 1 plus 2.05, which would give us 3.05. So that equals 588. And then we can divide 588 by 3.05. And that gives us 192 for our force of the feet, and that's force of the both feet. This is in newtons. So then to solve for force due to the hands, we can go back up to our equation. So basically we would have 192 plus F sub h equals 588. So to solve that algebra, we would just simply do 588 minus 192, which would give us 396. Newtons. But the only problem with this is that F sub F and F sub H are for both of the hands and both of the feet, but our prompt is asking for each hand and each foot. So then we would just simply have to divide both of these numbers by 2 to find our answers. So we do force of the foot of 1 would just be 192 divided by 2. Give us 96 newtons. And then force of the hands of 1 is the same method, so we would do 396 divided by 2, which would give us 198 newtons, which is our answer to solve the problem. And so if you want to do this with yourself, you would just have to plug in your own mass up here. So this person's mass was 60 kilograms. And after that, you'll be able to find the force of one hand and one foot for doing a push-up for yourself.